Let's look at the computation of a polar integral. In this particular case, if we look at the limits of integration, we can see that theta runs from 0 to pi, and r runs from 0 to 5 cosine theta, and the integrand is just r dr d theta. Well, we know from change of variables theorem that that's just the area element. That is, dA is r dr d theta. Now, based on what we know about polar coordinates, this region actually describes the area enclosed by the circle here. That is, from our last problem, we see that the center will be 5/2 0, and the radius will also be 5/2. So this is always twice the radius. And so we shaded here in the red, and note that this integral here is just the area of that region. And then you think, well, I know the area of a circle, that's pi r squared. And so this is actually a good way to test your ability to do double integrals. You already know the answer. So down here I've written area of circle. So let's just go ahead and do the computation to get practice with the double integral in polar coordinates. So I've written here again that this just basically corresponds to the area of region R. So now we integrate with respect to r squared over 2, and evaluate between the two limits here. Of course, the lower limit giving us 0. Upon evaluation, we factor the 1/2, and we get a 25 cosine squared theta d theta. So now it looks like we're in calculus 2. So again, what we want to do is factor the 25 and just use the power reducing formula for cosine squared, which is 1 plus cosine 2 theta divided by 2. So now moving to the next line, we can now break up the integral. That is, we can factor the 1/2 and get 25 over 4 integrating d theta from 0 to pi. And then, of course, we need to rig this because of the chain rule. So we need a 2 instead of just a d theta. We need a 2 d theta. So we factor that 1/2. So we get 25 over 8, 0 to pi, cosine 2 theta, 2 d theta. Now, of course, this particular integral is just 25 over 4 times the difference in the limits, pi minus 0. And then, of course, here, the antiderivative of the cosine is the sine. So we get 25 over 8 times sine 2 theta evaluated 0 to pi. Now, of course, for this particular term, we get 25 pi over 4. And then, of course, here, upon evaluation, both of these terms are 0. So, indeed, we do get the area of the circle, which is 25 pi over 4. So, just look at this particular example as a good way to recognize the area element and polar coordinates, and also a way to check your work doing a problem that you learned how to do in high school geometry. And we are done.